Imagine for a moment that the Kryukovsky Bridge stood as an artery to life, pumping supplies, hopes, energy, commerce, and survival across the great ribbon of the Dnipro River in Kremenchuk, connecting two halves of Ukraine in both geography and purpose. Then imagine that artery is struck, pierced not by disease but by missile, fire, and intention, suddenly severed, the flow of what once seemed secure and inevitable disrupted, the cost measured not only in steel and concrete but in livelihood, defense, and future. Hello everyone, welcome back to the Global Conflict News channel. Please subscribe my channel. Today the story is one of fracture and consequence, Russia's strike that has cut Ukraine's war artery in half as the Kryukovsky Bridge falls. The bridge, a critical link, now lies partially destroyed. The repercussions extend far beyond twisted girders and cracked concrete, they ripple through supply lines, civilian life, military strategy. The bridge's exterior, its interior functioning, the performance it offered, its safety structures, its unique position in Ukraine's logistical matrix, the price paid in damage and delay, all of these deserve attention. The conclusion must wrestle with what this strike means not only for today but for tomorrow. The structure spanned the Dnipro River at Kremenchuk, one of the few crossing points in the Poltava region, carrying both rail and road traffic in parallel. Its rails borne the weight of heavy military and industrial trains, its roads the steady hammer of commerce traffic, trucks laden with fuel, food, equipment, civilians commuting, goods flowing in every direction. Its external skeletal bones were steel supports rising from the riverbed, concrete piers pushing through shifting currents, a central span capable of being raised to allow river navigation, and beside it lanes of highway ribboned across the water's surface. Approaching from either bank, one saw on one side heavy industry, oil refineries, steel works, and rail yards, on the other, communities, agriculture, river shipping, and further transport nodes. The bridge was exposed to heat, cold, ice in winter, high water in spring, the sun's expansion of steel, rain, rust. Weather beat against it, and human use taxed it. Yet through all that it stood because it had to, because there were few alternatives, because the river is broad, powerful, because geography is unforgiving. Within that external frame lay the deeper interior of what made the bridge more than a physical object. Within its steel beams and concrete pillars ran the lifeblood of Ukraine's war effort and civilian life alike. When trains rumbled across, they brought ammunition, tanks, fuel, spare parts, food. Those rail lines were timed, controlled, signals set, tracks maintained. Side by side the highway lanes took trucks laden with goods, trucks carrying civilians, essential services, buses, deliveries. Below the deck, the girders bore weight, inside the joint welds held steel plates together, inside the concrete, rebar resisted compression and tension, the raising span mechanism nestled complex hydraulics or motor systems, cables, counterweights. Inside those supports, lining the piers beneath water level, foundations driven into riverbed, scoured perhaps by river currents, degraded over time by water, possibly undercut by erosion, silt accumulation, rust, fatigue. Maintenance crews, engineers, inspectors prowled inside both visible and hidden areas, examining for cracks, rust, fatigue, signs of failure. Signals for trains, road markings, expansion joints that allow for heat-induced shape changes, these interior features allow the bridge to function, to perform reliably. The bridge's internal dependencies were vast. It depended on consistent maintenance, periodic inspections of load-bearing members, of joints, of bolt connections, of rail alignment, of road surface integrity. It depended on weather forecasts, river level monitoring, flood risk, ice formation under piers. It depended on backup supply for materials, steel plates, bolts, hydraulic parts, concrete. It depended on electricity and power for any mechanical systems, lights, signaling, the raising span. It depended on security, both from accidental damage and intentional strike, to defend against missile, drone, artillery attack. Internally, the bridge was threaded into Ukraine's supply chain. Railway hubs that sat farther west delivered cargo to this bridge, from this bridge goods fanned out to eastern regions. Alternate routes existed but were longer, more hazardous, less efficient. Inside the logistical schedule, trains passed at specific intervals, road convoys timed, river shipping coordinated. If any component inside that chain broke, if the tracks were misaligned, if one pillar was destroyed, if road surface collapsed, if hydraulic mechanisms jammed, everything slowed or stopped. During the strike, internal damage was inflicted deeply. Pillars that held up spans collapsed or were severely compromised, the load distribution shifted in ways that stressed adjacent supports. The raising span mechanism likely suffered damage. Gears, support trusses, motors, control systems hit or at least exposed to blast, possibly misaligned. Adjacent steel beams may have warped, joints cracked, welds fractured. The concrete deck where vehicles crossed may have been compromised, sinks forming, parts missing, surfaces unstable. River currents and water pressure against damaged supports exacerbate problems, undercutting, shifting foundations, possible further collapse under load or from vibrations. Rail tracks, which require precise alignment, may have buckled or shifted, making train traffic dangerous or impossible. Road lanes may lie broken or missing, making heavy vehicles unable to cross, restricting traffic to lighter vehicles or nothing at all. Inspection crews must now map the interior damage, underwater divers, structural engineers, risk assessment teams. They must determine which pillars are salvageable, which spans need replacement. The raising span mechanism must be examined. Is the motor shaft bent? Are bearings destroyed? Are control wires severed? Is the mechanical linkage intact? Is the counterbalance still working? If those systems inside are ruined, river navigation could be blocked for large vessels. The thickness of steel, the condition of welding seams, the state of rivets or bolts, all internal details matter. Time for repair depends on accessibility. Underwater work is hard, river conditions, weather, danger of further attack slow progress. Replacement steel components must be manufactured or brought in, concrete must cure, alignment must be precise. Performance before the strike had been strong but not perfect. The bridge carried high loads, carried multiple trains a day, some sources noted around 18 military air supply trains daily. Road traffic was heavy, the route was efficient, supplies, fuel, ammunition could move across without long detours. Civilian traffic too depended on the bridge for movement of goods, transport of people, economic connections. It was a conduit of capability. After the strike, performance is greatly diminished. Train service is delayed, likely suspended in some segments, road traffic restricted or closed in sections, large vehicles possibly banned, river shipping perhaps blocked if the raising span is not operational. The efficiency of operations drops, longer routes must be used, fuel costs rise, risk of damage or ambush on alternate roads increases. Reliability is compromised, timetables disrupted, supplies arrive late or not at all. Safety features that once offered protection now tested severely. Structural safety built into load limits, into redundancy of supports, into inspections and maintenance. Traffic safety features, road signage, warning lights, perhaps structural monitoring. The raising span with safety interlocks designed to prevent passage of vehicles when raised. In wartime, additional safety from air alerts, defensive capability, patrols or surveillance of drones and missiles. But the strike shows that those safety nets were insufficient. Perhaps early warning existed, perhaps not, perhaps air defense coverage had gaps, maybe protective measures were compromised. Civilian safety is imperiled when infrastructure is destroyed. Road users could be hit by collapse, boats using river could be threatened if the span collapses, trains could derail if tracks warped, debris could fall into river or roadway. The internal safety margin inherent in the design, how much load a pillar can lose before collapse, how much damage a span can take before failure, has been exceeded or at least momentarily compromised. This bridge was unique in more than its physical construction. It held a singular place in Ukraine's transport network. It was among a very few crossings of the Dnipro in that region. In Poltava region it was one of the only viable crossings for much traffic. The geography of the river makes detours long, expensive, dangerous, alternate bridges are far off, necessitating long drive times or reroutes. Its dual role servicing both rail and highway makes it doubly valuable. Its inclusion of a movable central span for river navigation adds to its value. River cargo, shipping of fuel or raw materials, supply via water, all depend on access. The industrial weight of what it connected, oil refineries, steel works, rail yards, heavy manufacturing, makes its loss felt not only in military supply lines but in civilian economic life. Militarily, it served as major arteries for forwarding supplies to front lines, cutting it damages Ukraine's operational tempo. Symbolically, destroying or damaging such a key artery carries psychological weight. It sends a message of reach, of capability, of disruption. The price paid is not simply in the cost of steel and concrete. The physical damage is enormous. Pillars lost or severely damaged, spans cracked or destroyed, track alignment disrupted, road surfaces broken, hydraulics of the movable span compromised. Repair costs may run into tens or hundreds of millions of dollars, depending on the extent, the cost of materials, specialized labor, time. Logistical cost is heavy, supply convoys delayed or rerouted, trains cancelled or reduced in load, military units downstream may suffer delay of ammunition, fuel, parts. Civilian cost, food, medicine, consumer goods delayed, transportation of people disrupted, costs of detours, of alternative transport, rising fuel costs, perhaps even shortages. Industrial cost, factories may idle waiting for raw materials or fuel delivered via the bridge, refineries may lose throughput, shipments may be delayed or lost. Human cost, risk of casualties during the attack, of injuries, civilians stranded, of ambulances diverted, of emergency services delayed. Psychological cost, fear, uncertainty, morale damage among civilian population and among military logistics planners, the sense that infrastructure once considered safe is now vulnerable. Strategic cost, loss of redundancy, need for alternate routes which may be weaker or more exposed, increased risk in transport, diversion of resources to repair and protection rather than expansion or other needs. The time cost, repairs take time. Even after repair begins, capacity may be reduced during repairs, full service may take weeks or months, river navigation may remain blocked, train speed may need to be limited. In conclusion, the fall of the Kryukovsky Bridge is more than just the collapse of a structure. It is a strike at the connective tissue between the front lines and the homeland, between supply and demand, between industry and the consumer, between hope and stability. This attack has exposed vulnerabilities in Ukraine's logistics system, in maintenance, in protection, in redundancy. The bridge's destruction or partial destruction reshapes routes, forces adaptation, imposes cost, delays, danger. Ukraine must now assess, repair quickly or build alternate routes, strengthen protection of other critical infrastructure, expand surveillance, air defense, early warning, re-evaluate what once seemed safe. The ripple effects are broad, for military operations, for civilians, for economy, for morale. Yet, even as damage is assessed, repair planned, alternatives considered, there remains opportunity, for innovation, for dispersed logistics, for agile response, for renewed resilience. The artery may be cut, but systems remain, people remain, the will to overcome remains. The fall of Kryukovsky Bridge marks a steep setback, but in its aftermath lie the seeds of adaptation, determination, and reconstruction.